Will China or the US retrieve samples from Mars first? Who decides what James Webb is pointing at? And will AI be a benefit to science and astronomy? Answers to all these questions and more in The Question Show. It's time for The Question Show. Your questions, my answers, as always, wherever you are, across my channel. If a question pops in your brain, just write it down. I will gather them up and I will answer them here. All right, let's get into the questions. Billions and billions of stars. Fraser, will China beat the US in getting Mars samples first? I mean, obviously, we don't know if there's going to be some issues, some budgetary problems, some failures of the mission that will change the timeline. But right now, on paper, or I guess, in engineering, the plan is that the Chinese are going to be sending their sample return mission to Mars in 2028. So in 4 years from now, they're going to launch their sample return mission to Mars. It's going to arrive at Mars, it's going to collect a sample, and it's going to return that sample back to Earth by 2031. And so you could imagine there's a delay, there's a problem with the engineering, and they have to push it back one of these Mars windows. They don't launch in 2028, they launch in 2030. And then they don't get their samples back until 2033. I can't imagine taking any longer than that. They have demonstrated that they can retrieve samples from the moon. They are multiple times from different parts of the moon. They're going to be sending their Chang'e 7 mission, Chang'e 8. So they're getting really good practice. They have also sent a lander and a rover to the surface of Mars. So they know how to be able to get down onto the surface of Mars, which is relatively complicated. And so the last piece of the puzzle is, can they have an ascent vehicle that can take off from Mars and bring that sample back home to Earth? Now, it's not going to be as complicated and fancy as what NASA and the European Space Agency were planning. They were planning to take all of those samples that NASA's Perseverance rover has been collecting on the surface of Mars, all these titanium samples, like 20 plus of these samples, and bring that back to Earth, which would be amazing because each one has been chosen very carefully by this rover from an all-you-can-eat buffet of sample locations on Mars, and one of the best places on Mars, Jezero Crater, to search for evidence of life. So those would be really good samples. And so a couple of months ago, NASA announced that there was a problem with their sample return mission, and they were sort of putting the whole plan on hold, that the budget was creeping up, it was going to get too high. And so they went and had a big rethink. They brought in a bunch of their industry partners and tried to figure out a way that they could bring down the costs. And a couple of weeks ago, they announced that they've got a couple of options that they're considering. One is a scaled down version of the Mars sample return mission that uses a beefier version of the Sky Crane. This is this really cool rocket that softly dropped Perseverance and Curiosity onto the surface of Mars. And so they have a version that's like a little bit bigger than that. It would be capable of dropping the sample ascent vehicle onto the surface of Mars. And then Perseverance would meet up with it, hand over the samples. It would then fly off back to Earth. The other possibility is that they'll work with one of their partners. So they Blue Origin or SpaceX, and they will send one of their spacecraft to the surface of Mars and then meet up. I guess Perseverance will come. I can imagine Perseverance trying to hand samples to Starship that's sitting there on the surface of Mars, but that would be the possibility. And in both cases, you're looking at roughly similar costs. And there are real advantages and disadvantages to both, right? Following on with the Sky Crane concept. I mean, this is a tried and true technology. NASA knows how to build this thing. They proved that it worked with both Curiosity and Perseverance. A scaled up version should work as well, and you get exactly what you want, which is you get those samples and you bring them back home to Earth. With a private mission, this is sort of an extension of the commercial lunar payload program, like what you have with the Firefly lander, with all of the various landers that have attempted to land over on the moon. And so far, when I'm recording this episode, the CLIPS program hasn't really paid off. We've seen failures of various missions, which is really too bad, because the idea is pretty good, which is that you fund a bunch of individual separate companies. They build the capability to be able to send landers to the surface of the moon. NASA no longer has to be involved in that process. They just deliver instruments, and then they are guaranteed a trip to the moon. And so you can imagine that same thing, that NASA delivers instruments to various partners, and they're guaranteed to deliver those to the surface of Mars. And so in the short term, probably just the direct go with the sky crane option is the one that makes the most sense and has the least risk. You're not dependent on the timelines of Blue Origin or SpaceX developing entirely new complex hardware. But in the long term, I really like the idea of having this commercial partner that NASA has all of these instruments they want to send to the surface of Mars. And you just go, well, there's a Starship and there's a Blue Origin lander going to Mars every 2 years. And they just put a bunch of these instruments on board and then they get the science without having to get really complicated about it. And so it's more of an investment into the future. So will the Chinese beat the US to getting the samples? Absolutely, right? Like something really strange has got to happen for the Chinese to not get their samples back before the Americans do. The US is probably looking at into the late 2030s and maybe even into the 2040s before they get their samples back from Mars. So they should probably beat them by close to a decade. Fiat hater. What happens to the information contained in matter that falls into a black hole? Have we deciphered this yet? So this is the information paradox, and this is this idea that information that falls into the black hole is seemingly destroyed when black holes evaporate. And I sort of need to go back a little bit here. So when you think about a black hole, right, it is going to be able to absorb matter, and matter is going to fall into the black hole, and energy is going to be able to fall into the black hole. And the traditional thought was that even if this stuff is falling into the black hole, the information that describes this is preserved. That, you may have a planet that goes into a black hole, and that planet is made up of all of these individual particles. And if you went down to the quantum level and you described every single field and every particle that's in that, you'll have this information. And one of the rules in physics is that this information can't be destroyed. It can be kind of changed, it can be transformed, but it can't actually be destroyed. And so all of this stuff falls into the black hole and is beyond the event horizon, but it's still preserved. It's still in there. And then the big idea that Stephen Hawking came up with was that he realized that over vast periods of time, black holes should evaporate. And they should evaporate in this sort of black body way where the particles that are coming off of the black hole have no connection to what it was that fell into the black hole. And so this idea that information must be preserved is lost. And this is this paradox, the information paradox. And this is a puzzle. And this is something that has been troubling scientists ever since Stephen Hawking came up with this. And we don't know what the answer is. People still put out papers all the time and they argue about different things. And so, there are themes to the answers that people have been providing. One of the themes is that the information of the material that falls into the black hole is actually written into the event horizon of the black hole. There's this idea of the holographic principle that it's sort of like a weird coincidence that the event horizon of the black hole has enough surface area to describe the information that's contained within the black hole. And so it may very well be that even though stuff is falling into the black hole and it's evaporating later on, that this information is still preserved on the surface of the event horizon. The other possibility is that somehow this information is actually preserved even when it radiates through Hawking radiation, that it may have been transformed, but the information is not completely gone. It's still there, and you could theoretically decode it if you could grab every single particle that is evaporating away from the black hole. But the other possibility is that it is destroyed, and that this assumption that information can't be destroyed is wrong. So, we're still in early stages. A lot of people have come up with some really interesting ideas and made progress in this complicated physics question. But until, we get a chance to actually see Hawking radiation happen, it's going to be hard to know really what's happening to the information. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who's already subscribed, and welcome to our recent newcomers: Dream Driver, Brian Deshawn, Anthony Schatzenhofer, Simon Solberg, Pandra Bear Johnson, and Steve W. Join the club at patreon.com/universetoday. Tommy's Woodpile Adventures and Tall Tales. Who gets to sit in the driver's seat for JWST? Who gets to decide what science is being done? So JWST is a collaboration between NASA, the European Space Agency, and the Canadian Space Agency. And they've all contributed instruments and funding to build this thing. But the actual day-to-day operations of James Webb are run by the Space Telescope Science Institute. And this is the same group that runs the Hubble Space Telescope and some other telescopes. And the way both Hubble and James Webb work is that there is a group that meets to discuss the various proposals and allocate time to James Webb. Now, it's free for anyone around the world to be able to make proposals. Any institution can do it. You don't have to pay any money to use either Hubble or James Webb. You just have to make the science case that what the questions that you're attempting to answer, the research that you're trying to do is going to give a benefit to humanity's scientific understanding of the universe. And so then the working group will look through all of the proposals. They make a call every year. They call for proposals. Then they have a deadline, and then they look at all the proposals and they start to allocate the time on the telescope. Now, it's way oversubscribed. Even Hubble is way oversubscribed, which means that more people are applying for time on the telescope than can actually get access in time on the telescope. But still, they do the best they can to fit in everybody's proposals. They may say, we can't give you the 1 full year of James Webb time. Can you dial it down? Can you come up with a smaller use case? And so a lot of the times people are proposing, some first version that is the smallest possible time. And then if they figure out something, they'll come back around, ask for something bigger. And so then the steering committee goes through all those proposals, looks at the time they have on the telescope, and then allocates that time to those people. And they get notified, they get access to a special website where they can upload their detailed information. They can download the science data when it comes in. And that's how the telescope is driven. And it's very similar to all the telescopes around the world. They have a very similar situation, which is that there are groups with each telescope that are allocating the time to those telescopes, and they're just waiting for people to come up with, to pass along their scientific proposals for them to be able to use them. Greg Dodd, why do we need science? Now we have AI. So the AI right now is not very good. That's the problem. That the very best artificial intelligence that humanity has created so far, I'm thinking about, say, OpenAI, their O1 model, DeepSeek's R1 model, Claude, they hallucinate, they confabulate, they make stuff up. And so it's really hard to come up with something that can just think science. The way science works is it's done through observation and experimentation, that you come up with a hypothesis, you perform some kind of action in the real world, and then you see what the results of that action are. And then you can try and make some kind of scientific conclusion about what it is that you're seeing. But you can't just think your way to science. And so the piece that's missing with artificial intelligence today is that physical connection. Now, there have been some incredible discoveries that have been made. Things like, say, DeepMind's AlphaFold, where you have this machine learning algorithm that has watched enough protein folding that it can predict the different ways that proteins are going to fold. And it appears to be very accurate. And so there are going to be these small regions where there's real value in using machine learning to be able to make a lot of progress in artificial intelligence. But for a lot of stuff that we really care about, increasing our lifespans, giving us new forms of energy, developing new kinds of materials, chemicals, drugs, transportation systems, things like that, it's going to require some kind of interaction in the real world. Now, we are seeing some of this stuff start to play out. So there are examples. I've seen these really cool robots that they're in this collection of different metals and materials. They've got all kinds of ways they can do chemistry on this stuff. And then they're just running through this giant list. And they're going, well, if we take a little bit of antimony and we add it to titanium, and then we condense it on a thing, and then we titrate it in, and then we add that to aluminum. Does that give us a metal with any kind of interesting characteristics? And so you're having what used to be this sort of people doing materials research would have to work very slowly. This robot is just going 24/7. It's got access to all the things. It's mixing and matching different kinds of chemicals together to come up with various outcomes. And people have done some really interesting work in drug research where you can kind of take the molecules for known chemicals, and then you can feed that into artificial intelligence, and then it can make some predictions about the kinds of chemicals that might have certain attributes that you're looking for. It can search through this knowledge space to give you some kind of idea. But a lot of this progress is very slow. I think in the short term, what we're going to see is artificial intelligence being really helpful for double checking results, for finding mistakes, checking the math. So with the newest model from OpenAI, their O3 model, we haven't got access to this yet. It's going to happen pretty soon, I think. But they were able to then go through science papers and just with a fine-tooth comb, double check the math in those science papers. And the new versions, like O3, apparently is very good at math. And they're finding mistakes. And so you can imagine that someone's going to go, well, let's just take every science paper that's ever been done in the last decade, and we'll just feed them one by one to O3 and see if it can find any mistakes. And I'm sure they're going to find a zillion mistakes. And then these are opportunities. Papers that were thought to be very serious science, it'll turn out there was a basic flaw, that I don't know, you probably heard the mistake where people realized that the black plastic isn't as dangerous as we thought, and we all threw out our black plastic, and maybe we didn't need to. But anyway, so I think in the short term, AI is going to be this great double checker. But in the long term, it's going to need hands. It's going to need a way to do research in the physical world to really progress science. But that's it's inevitable. It's just a matter of time. So I think, scientists aren't going to quit their day jobs today. They're going to incorporate AI more and more into the work they do in the medium term. And then in the long term, we're going to see these really sort of expansive scientific projects where you can just use a ton of robotics and machine learning to try and do a lot of experiments simultaneously. And I think we're going to see this real acceleration in science for a while. Kirk Wagner. If radiation in space is so severe, why is the idea of panspermia even considered? The way to deal with the radiation in space is to put protons between you and space. So to surround yourself with rock or water. And you don't need very much. You just need about a meter of material. And with that, you're effectively protected. You experience zero of that radiation load. And so the idea with panspermia is that you have this giant meteor that crashes into, say, Mars, and it kicks up all this debris into solar orbit. And then these giant, these rocks are going to be tens of meters, hundreds of meters, even kilometers across that have been blown away. Like you imagine something really big hitting Mars. And so this debris, as long as it's got like a meter of rock, if you have a chunk that is 10 meters across, then the outer meter of that is going to be protective. And then inside, you're going to have bacteria that is now going to hibernate and wait. And it can be protected there for hundreds of thousands, if not millions of years. And then it finds its way to Earth, and then it enters the Earth's atmosphere, breaks up, but doesn't actually boil alive any of the creatures inside this rock. And, there was that, I don't know if you saw that rock that hit this sidewalk in Canada. And it very much looked like someone took a rock and just smashed it into the ground. And that's because the rock, as it entered the Earth's atmosphere, crumbled and broke up, and then it hit terminal velocity. And then the rock is just falling. And so it doesn't carve out a giant crater. It's like someone just threw a rock at the ground at whatever terminal velocity is for a rock that big, a couple of hundred kilometers an hour. And so it's surprising, but theoretically, life can withstand every part of that journey, from the crashing in, from being launched into an orbital trajectory, floating in space for hundreds of thousands, if not millions of years, and then re-entering the atmosphere of another planet. I mean, scientists have found bacteria at the bottom of the ocean that has been hibernating for millions of years, and they've been able to resurrect it. So life is surprisingly hardy when it's in bacteria form. All right, those are all the questions that we had in this episode. Thank you everyone who went onto our channel and asked questions in the YouTube comments, as well as everybody who showed up for the live show, which we record every Monday at 5 p.m. at some time in the world. So you're gonna have to check and see when the next event is coming up and see if it's appropriate for your time zone. Now I'm gonna ask for some sci-fi recommendations, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew M. Gross, Bear Lake Roofing, David Giltonan, David Matz, Dennis Alberti, Dustin Cable, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Roebuck, Sean Sargent, Spiderswap.io, Stephen Fowler-Munley, Thomas L. Skadron, and Vlad Chiplin, who support us at the Master of the Universe level. And all our patrons. All your support means the universe to us. So my wife and I watch a lot of science fiction, television, anime, and we're out. We've watched it all. We've come to the end of the internet. And so I would love to hear what you're watching, maybe stuff that I've missed. So if you have some recommendations for maybe some more obscure science fiction, either movies or television, things that you've really enjoyed, why don't you go ahead and put them down into the comments below and I will try to add them to my queue. But also everyone who is watching this will also get some ideas and some inspiration. They'll see them in the YouTube comments and hopefully we'll all have lots more to watch. All right, we'll see you next time.